Hello everyone. This is Dhanlakshmi, Assistant Professor of AAA Department from RMD Engineering College. In this session, I would like to discuss about DMA, right? Or we might be knowing about DMA. So we are very familiar with DMA. What is DMA? DMA is the direct memory access. So in embedded systems, where in Unit 1, we have the introduction of embedded system where the DMA concept is also there. So where we have to discuss about direct memory access. We'll see what is DMA, direct memory access. Right, so DMA, direct memory access. The name itself tells us that as we know that any action has to be done, that has to be done with the help of a processor. Without the involvement of processor, no action will be done. But this direct memory access is a one where we have a DMA controller, direct memory access controller. So this DMA, direct memory access, in the sense where the data from the IO device can be written or write into a memory directly without the involvement of a processor. That is what called as the DMA, direct memory access. That is, without the involvement of the processor, the memory and IO device can write or read the data. Within, they can communicate, right? So that is, the data from the input output device can be written or taken from the memory without the involvement of the processor. So that is called as DMA, direct memory access. So for this we have a DMA, DMAC, right? DMAC, we have direct memory access controller. So this controller will take care of that. So here you can see that this is our processor. So as the name tells, it is a direct memory access without the involvement of a processor. So here we have a memory device and this is our input output device, right? So they both will communicate, that is, they both will transfer the data. They both will transfer the data without the involvement of the process. So that is about DMA. Right, and this has to be supervised by a controller, that is actually the DMA controller, right? So DMA, the DMAC we say. So here you can see that whenever the DMAC action is going to take place, this DMAC controller, that is DMA controller, this DMA controller will be sending an acknowledged, DMA controller will be sending a hold signal. DMA controller will be sending a hold signal to the process saying that you hold it, right? For that, the processor in turn will send a signal called hold acknowledge, right? So HLD stands for hold signal. So here you can see that the DMA controller is going to send a hold signal to it. One second, let me take yes point. So you can see that the DMA controller is sending a hold signal here. It is saying that you hold on, right? I will take care of this memory access action. Whereas the processor in turn will be sending a hold acknowledge, HLDA, right? Once this during this DMA action, the processor will be idle, idle here, and ideal in the sense it will not involve in this process. It will not involve in the memory access process where the DMA controller will be taking care. So here you can see that once the processor is holded, here you can see that here this signal MRW stands for memory read write, and this is our IO device, that is input output device. Again, we have IO read write. So because if it is an input device, we are going to read from it, and if it is an output device, we are going to write on it, right? So therefore we have IO read write, and this is our device request and device acknowledge. So here we have a number of IO devices, input and output devices. So the device request signal will be given to the controller, DMAC controller. Based on the request given by a particular IO device, the acknowledgement signal will be given by the DMA controller to that particular device. Is that clear? So we have a number of IO devices. If any one particular input or output device is going to give a request, that request will be acknowledged by the DMA controller. And once that particular device request is accepted, and that IO device and memory will be communicating, will be sharing the data, right? So here we will see in detail. So here we can see that those things in detail, or right. So here we can see that one second, right? So here we can see. So in this, we have, since the memory and the IO devices are going to communicate, here we have 4 possible operations are possible, right? That is either with IO device to memory and memory to IO device, or memory to memory and as well as IO device to another IO device. So there are 4 possible there are 4 possible operations There are 4 possible operations we have. One is with memory to memory, and then IO device with another IO device, or with memory to IO device and memory to IO device, or from IO device to memory. So here we can see that we have many modes of operation in this DMA, where a single block transfer, chain block transfer, link block transfer, and flyby transfer. So here let me take the first one, that is single block transfer. So you can see that single block of data is going to be transferred from the IO device to the memory. So this is the logic here, where we can see that a single block of data, right? A single block of data, we're going to transfer that into a memory. This is the idea. So here you can see that, one second, let me take the pen again. So you can see that this is our processor and this is our DMAC. DMAC is our direct memory access controller, where it is going to take care of this DMA action, right? So once this DMAC sends the whole signal, and the CPU will be acknowledging it, hold acknowledge. And see, for example, here I have a memory. This is our memory and this is our IO device. For example, this is the operation I'm going to take now. For example, if data is there available in the input device, that data I'm going to store it in the memory, right? So this is our idea. For this operation, without the involvement of the processor CPU, the DMAC itself will take care of it. That's why we say the direct memory access. For that, this CPU will will do the construction for a descriptor, will be describing what it has to do. Right, so the it will give the construction, it will construct it will do the construction of a descriptor. Then it will send a command to the DMAC saying that you take care of, that is, you take care of this particular action where the data from the input device has to be stored to the memory, right? And once it receives the command, once this DMAC receives the command from the CPU, now the CPU will be holded on, and therefore the DMAC will take care of this action now. So once it receives the command from the CPU, the next immediate step, what it will do is it will identify that device, that input or output device. So here I've taken the data to be transferred from the input device to the memory. So therefore it will identify the input device and device address, right? So device base register will be carrying the address of that input device. So therefore, whichever input device where you're going to get the data, where you're going to load the data from that device to a memory, that device address will be here. Right, device based register will be having the address of the input device, right? So what will happen, it will go to directly, since it is having the address, it will directly go to that input device. It will directly communicate with that device data register, where it will directly go to that input device. From that input device, it will get the data and put the data into the temporary data register, right? So after getting the command from the CPU, it will go to the address. It will have the address of that particular input device, and it will go to that address. Finding that address, it will find that device, right? Once it found that device, it will get the data, whatever data that has to be put into memory, that data, it will get it and it will put it in the temporary data register. Right, this will all happen and this will be up to one cycle. Then in the immediate next cycle, what it will do, it will have the memory based register, that is the address of the memory where you're going to put that data, right? So that address will be here. So from this, what will happen, the next cycle, it will go to that particular memory address, and already it has the data from that input device. Already it got that data from the input device, and that data is stored in the temporary data register. Now, once after reaching that memory address, right, that particular memory address, now this will transfer this temporary data to that memory block. Is that clear? So therefore, this is how it is happening. So once it receives the signal from CPU, once it receives command from CPU, it will go to that input device and get the data and put it in the temporary register. And the next cycle, it will have the memory address also where it has to put the data. That it will go to that particular memory address and then transfers this memory data. That is, it transfers this temporary data to that memory block, right? So this is how it keeps on repeating until the block length reaches. That is, for example, how many block of data have to store it. That data will be fed by the descriptor to the block length register, right? So how many length or how many blocks of data have to be stored there, that data is given by the descriptor and that is stored in the block length register. So until that length is reached, this action will be keep on repeating. Right, once that length has reached, then it will send, then the action will be stopped, and then this DMAC controller will be sending an interrupt request, IRQ, right? It will be sending a interrupt request signal, so that it is saying that the process is over. right? So therefore, once a block of memory is stored, it keep on transferred to the memory, and once the length has been reached, until the length reaches, until that length has been attained, it will keep on doing its operation. It will getting the data from the input device and it will put it in the memory. Once the length is reached, then this DMAX will be sending a interrupt request signal to the CPU saying that the process is over, right? So this is how the DMAC, the direct memory access DMA controller. DMA concept of DMA is without involving the processor, the memory can be accessed directly with the help of a DMAC controller. It is DMA controller, DMAC, right? So this is how it works here. So during this DMA, the processor will not be involved. All these actions will be taken by the DMAC itself. That is DMA controller itself. And here the operations are either it can be the data transfer sharing between memory and IO device. That is from memory to IO device, or from IO device to memory, or it can be from memory to memory itself, or it can be from one IO device to another IO device, right? So one input device to another one input device to another output device. So these are all the possible operations of DMA, right? So thank you.